All right, let's get into it. Today, we're going to tackle one of those big, beefy questions you always find lurking at the end of an exam paper. We're going to break this probability problem down piece by piece, and I'll show you exactly how to lock in every single one of those marks. Okay, let's do this. And here it is. You can think of this as the final boss of the probability section. I know, it looks intimidating. It's all words, there's algebra involved, and it's worth a massive 5 marks. But here's the thing. If you have a solid game plan, it's totally beatable. Okay, first things first, before we even think about picking up a pen, our number one job is always the same. We have to carefully read and pull apart the question. What info are they giving us, and what, exactly, do they want us to find? Getting this straight from the get-go is half the battle, for sure. Now, the real trick to a question like this is all about translation. We've got to turn these sentences from plain English into the language of math, which in this case is algebra. This is how we build a little model of the problem that we can actually work with and solve. So, let's lay out the facts. We're going to let n be the total number of counters. The question says 3/5 are red, so that's 3n over 5, which means the rest, 2n over 5, have to be yellow. Now, this next part is absolutely crucial. She takes 2 counters without replacement. That little detail changes everything. And finally, they just give us the probability of picking 2 of the same color. Just getting the stuff down on paper is your first big step towards those method marks. Right, we've got our ingredients. The next step is to actually build the probability expressions. We're going to figure out the probability of picking 2 reds, and then we'll do the exact same thing for the yellows. First up, P, red, red. All this fancy notation means is what's the probability that the first counter she pulls out is red, and then the second one is also red, remembering that she didn't put that first one back. So for that first pick, the chance of getting a red is just the number of reds, which is 3n, over 5, divided by the total number of counters, n. You'll notice the n's actually cancel out here, which is nice. So the probability is just 3/5. But for the second pick, the whole game is changed. There's 1 less red counter and 1 less counter in the whole box. So the new probability is the new number of reds over the new total. So here's what it looks like all put together. To get the probability of both things happening, we just multiply them. And like we just said, that first bit, the 3n over 5n, that just cleans up to become 3 over 5, which is going to make our lives a whole lot easier in a minute. And for the yellows, you guessed it. It's the exact same logic. The probability of the first one being yellow is 2/5, and for the second pick, well, we've got 1 less yellow and 1 less counter overall. See the pattern? Okay, pivotal moment. We have our 2 separate probabilities, the chance of getting 2 reds and the chance of getting 2 yellows. Now, the question asks for the probability of getting 2 counters of the same color. That means red and red, or yellow and yellow. That word or is the big clue. In probability, when you hear or, you add. And this is the heart of the whole problem. The probability of getting 2 reds or 2 yellows is just the sum of the 2 probabilities we just found. And the question straight up tells us that this whole thing equals 41 over 80. We've just built our master equation. And there she is in all her glory. This is the equation we need to solve to find n. Honestly, getting to this point correctly is a huge win, and it bags you most of the marks for your method. It looks like a monster, I know, but from here on out, it's just a matter of being careful with our algebra. All right, time to roll up our sleeves. Welcome to the algebraic workout. Our mission now is to take that beast of an equation and wrestle it into submission until we can solve for n. This part is a pure test of your algebra skills, so just take it slow and steady. So, how do we get from that crazy-looking thing to this much nicer equation? Well, you're going to simplify the stuff on the left, combine it all into one big fraction, and then comes the really satisfying part. You cross-multiply to blow away the fractions completely. You just multiply the top of the left side by the bottom of the right, and vice versa. After you expand all the brackets from that cross-multiplication and shove all the terms over to one side, boom, we land on a quadratic equation. To be honest, this is kind of what you'd expect to see in a high-level question like this one. Now, all we have to do is solve it. So we can chuck this into the quadratic formula or use a calculator, and it spits out 2 possible answers for n. One is a nice, clean whole number, 40. The other one, well, it's a messy decimal, about 1 point something. So which one is our answer? Okay, deep breath. We are so close, and this is super important, we're not finished. Solving for n was the main event, but we have to use that answer to solve the original question. We're on the very last step. This is where we just need to use a bit of common sense. What does n even stand for? The total number of counters. Can you have 1-point-something counters in a box? No way. It has to be a whole number, right? So we can just take that messy decimal answer and toss it in the bin. We know with confidence that the total number of counters, n, must be 40. And here's the classic trap where people can lose a mark right at the finish line. You've got to read the question one last time. It doesn't ask for the total number of counters. It asks for the number of yellow ones. And we figured that out way back at the start. Yellows are 2/5 of the total. So we just need to calculate 2/5 of our total, 40, which gives us a final answer, 16. There are 16 yellow counters in the box. And that, my friends, is how you get all 5 marks. So we cracked it, but let's just think about that for a second. We throw out that one decimal solution because, well, you can't have a fraction of a counter. It just didn't make sense in the real world. It makes you wonder, though, doesn't it? When else does math give you an answer that's technically correct, but completely impossible in reality? Something to chew on. Thanks for sticking with me on this one.